So now we're going to look at the second part of the problem. That is, how do we find the sign of the answer? Well, let's say for example we had our values x and y, and let's say x is greater than y. Then we would have, say for example, plus 7 plus minus 5, and that would give us a value of plus 2. Now if we were to swap these round about, then we would have plus 5 plus minus 7, and that would give us a value of minus 2. So the order in which these appear would matter. Now what we're going to have to do is we're going to use the sign of x. So let's have a little look at the previous page, and you can see here that in order to get the correct answer here, that is the correct sign, you'll see here if we were to look at the sign of the answer here is positive, the sign of x is positive. The sign of the answer is negative, the sign of x is negative. The sign of the answer is positive and positive, negative and negative. And the same thing for this table here. The sign for the answer is positive, positive, negative, negative, positive, positive, negative, negative. So we can find the answer just by the sign of the answer just from the sign of x. Now this is going to work for us whenever the value of our x is greater than the value of our y. But it won't necessarily work for us whenever the value of x is less than the value of y. Sometimes it will work, sometimes it won't. So let's start putting together our basic algorithm. We know that in 32-bit floating point arithmetic, the first bit will tell us the sign of the result. So if it's a 0, it'll be a positive value. If it's a 1, it'll be a negative value. So we want a little mathematical algorithm that will allow us to go from the 0 and 1 here to the actual decimal positive and negative. And you can see how we're going to do that here. We know that the negative is given by a value of plus 1. So if we were to write minus 1 to the value of 1, well, anything raised to the value of 1 is just itself. So minus 1 to the power of 1 is just minus 1. So that would be our negative. Now a positive would be given by a value of 0. If we were to write minus 1 to the power of 0, then anything to the power of 0 is just a value of 1. So this in effect would now be our plus 1, so this would be a positive. So it means that if we were to write minus 1 to the power of either 0 or 1, then we would get the actual decimal value, which would be plus 1 and minus 1. So this is just a little mathematical trick we use in order to go from our binary to our decimal for our positive and negative numbers. So if we were to take our value for x and we were to split the value of x into the sign for x and the magnitude for x, then we would have the sign for x here would be minus 1 to the power of the sx, and y would be minus 1 to the power of the sign of y. And we would have the mantissa for x, we would have the radix raised to the power ex, mantissa for y, and the radix raised to the power of ey. So this is just our floating point number. So we can say that the modulus of x is just this part of the number. So it's really the number without the sign, and the modulus of y is just this part of the number. So the algorithm that we looked at before, it told us that if we were to take our value for x and we were to work out whether we had to add or subtract, well, we work out whether we add or subtract the x and y by determining the value SZ. Now SZ again is just the exclusive OR over SX and SY, but of course we have to write it in this format here, minus 1 raised to that power. So this here will give us the magnitude of the result, so really it will tell us whether we have to add or subtract the numbers. And this part out here will give us the sign of the result. So this here is our little algorithm we want to work through in order to get the correct values for all our 16 possible combinations of adding and subtracting positive and negative numbers, and also swapping the magnitudes round so the x is greater than or less than y. So this is us written the algorithm out here that we're going to use. Now at the bottom here you'll see there's a little circle, and this little circle stands for rounding. So we're assuming we're going to add or subtract the x and y, and after we've done that we'll round the final result. But what we're going to do is we're going to go through the 16 possible combinations, and we're going to see there's actually going to be 4 of them that don't quite work for us. So we're going to have to change this just slightly, and we'll do that on the last page of this video. So on this page I've got 8 possibilities of adding our 7 and our 5, and we've got another 8 possibilities on the next page. Now I'm not going to sit and read through every one of them. You can just pause this and have a look at them yourself, but let's just pick out one in particular. So let's say we pick out just at random this one here. We could have the value, let's say it's like 3 and 4, we could have minus x plus minus y. Okay, so in order to work through our algorithm, what we're going to have is we're going to have minus 1 to the sine of x. Well, the sine of x here is going to be negative. So a negative value is going to have a value of 1. So that's minus 1 to the power of 1. And then we've got our brackets here. And in our brackets, we've got the magnitude of x. So that's just plus x. And we've got the magnitude of y. So that's just our plus y. Now, in order to find out whether we add or subtract, we've got to multiply this thing here by our minus 1 to the power of z. Okay, so you can see here we're going to have minus 1 to the power of z. Well, what is z in this instance? Well, z is going to be the exclusive OR here. So we're going to have a value of 1 for the x, a value for 1 for the y, because they're negatives. And whenever we exclusive OR them, we get a value of 0. So it means then in this instance here, we're going to have minus 1 to the power of 0. So this is the little algorithm we have to work through. And if we actually put the values in, you'll see we'll get the right result. We put in minus 7 becomes plus 7. Minus 5 becomes plus 5. The minus 1 to the power of 0, when the power of 0 is just 1. So that's just plus 1. So it means that we're adding these two together. And we're going to multiply them by minus 1 to the power of 1. Anything to the power of 1 is itself, which is just minus 1. So we're going to have minus 1, and we're going to have 7 plus 5. So 7 plus 5 is 12, and we have the minus sign here will give us a minus 12. So I suggest you work through 2 or 3 of these yourself and convince yourself that the algorithm does actually work. And I've rewritten the algorithm down the bottom here. Now, the thing about this is there's actually going to be 2 of them here that don't work. So this little algorithm won't work for these 2 in pink. And you can see here that the algorithm doesn't work whenever the addition or subtraction actually gives you a negative number. So in this instance here, you can see that within the square brackets, we've got a positive, we've got a positive here, we've got a positive here, and a positive here, and they all work. As long as what's inside the brackets is positive, we know the signs are going to be given by the sign of the value of x. But if we end up with a negative here, then we can see here that whenever we work through the example here, we're not going to get the correct answer. So we're going to have to note that in this instance here, the correct answer is a positive, but the sign of x is actually negative. So it doesn't actually work for this instance, and it doesn't work for this instance here as well. So here are the other 8 possibilities. And I've marked off the 2 in pink that don't work. So for example, the answer here is going to be a negative value, but the sign of x is going to be positive. So it just doesn't work for this one. And again, it doesn't work for this one either. So it won't work whenever the subtraction or addition is given as a negative number within this square bracket here. So we're going to have to cater for that, and let's see how we're going to do that on the next page. So this is the final algorithm here. You'll notice that I've added a truth table. The value inside the square brackets here tells us the absolute value of the result. So it really tells us whether we're going to add or subtract the 2 numbers. The value outside the bracket here tells us the final sign of the result. So like we said, we've split this into two problems, finding the absolute value and finding the sign. Now in this truth table here, we've got the sign of x, which can be positive or negative. We've also got the sign of the value inside the bracket. So the value inside the bracket I've called MR. So the value inside the bracket can be either positive or it can be negative. So there's four possibilities here. If the value inside the bracket is positive, then we know that the sign is just going to be given by the sign of x. But if the value inside the bracket is negative, it means that the sign is going to be given by the negation of this sign of x. So for example, if we had a minus 1 inside the bracket here, and we had a 0 here, then it would mean we would have a minus times a positive, which would give us a minus, which would be the negation of this. So that would be, rather than a 0, it would be a 1. In this case here, if it was a 1, it would be a 0. So this is the final algorithm we're going to use in order to generate our adder and subtractor. So that's us worked out a mathematical algorithm for adding and subtracting our two numbers. Thank you for listening. I'll get you on the next video. Goodbye.